Hello and welcome. So I hope all of you have been doing well. I have been uploading our lectures via Zoom, and I will soon change them to YouTube. Actually, I removed them from Zoom so I can upload them to YouTube, and I hope to finish that today. Let's go ahead and start with today's lecture. I'm sure people will begin to join as we go through our lecture, but it'll be available to you to review on your own once we're done. Okay, I'm going to go ahead and share my screen. Oh, can you guys not hear me? You can hear me or no? Yeah, okay, all right.
Sarah says she can't, her audio isn't working, but she can still hear you.
Oh, okay, I muted everyone. So when you walk in, you're muted. If you want to unmute yourself, you can do that anytime. So maybe that's what Sarah is experiencing. So next to your screen, because you should have a screen that's yours of your face, like on the side or on top. If you put your cursor on it, you should have a little screen, a little video image, and a little like microphone image. So you want to unmute yourself, you just go ahead and press that button. I just automatically mute everyone just so we don't hear you like moving around, grabbing your pencil and stuff like that. So it doesn't create background noise. Because I know those microphones are super sensitive. All right, so we're gonna go over one section today and we'll call it a day. You know what you need help with, so if you can make it a point to go over these videos on your own if you want to review something. Also, your homework's available. I tried working on my math lab yesterday and it was working really slow for me. So I don't know if it's just too many people are on it at the same time, but things would get through. It just took a minute to load. So if you have trouble with it, let me know. Maybe we can contact Pearson together. All right, so in this section, 2.2, it's about more graphs. And I think 2.1 was more challenging. It had more to do with graphs. This one's kind of like an overview and a couple of more graphs. We're going to learn how to graph and interpret quantitative data using stem and leaf plots and dot plots, how to graph and interpret qualitative data using pie charts and Pareto charts, and how to graph and interpret paired data sets using scatter plots and time series charts. All right, first we have stem and leaf. Okay, so stem and leaf is helpful because it tells us two things. It tells us the number, the data. They're cool because it tells us the data, but it also kind of gives us a type of like a bar graph because we know how many we have in that range. So it also gives us an image of what we have. So we can see which ones there's more of. So let's read your slide. Stem and leaf plot. Each number is separated into a stem and a leaf. Similar to a histogram, it still contains the original data and provides an easy way to sort data. So here it starts by giving you this data, these are numbers, and we have 21, 25, 25, 26, 27, 28, 30, 36, 36, and 45. So the way we can set them up, you can use any value you like. These are your tens values. So we know that 2 stands for 20, that 3 stands for 30, and that 4 stands for 40. Now these values here are your ones. So you can think of it as 21, 25, 26, 27, 28, 29, because we're in the 20s. And so forth for the rest, like 30, 36, and 36. That's where all these values come from. But generally we have our tens and our ones. Now, if you're working with really big numbers, instead of tens, you can let that be hundreds or thousands. You can sort it however you like. Let's do an example. The data set lists the numbers of text messages sent in one day by 50 cell phone users. Display the data in a stem and leaf plot and describe any patterns. All right, so we have a lot of numbers to keep track of, right? So it's good to do like a rough draft stem and leaf. So let's make our rough draft for our practice stem and leaf. And it's worked out for us in a couple of slides away. But let's start thinking about it. So if you look at your numbers, take a minute to analyze them. Like, hey, what's your smallest number? What's your largest? So I'm taking a look and I see that I have a 16. So it might be our 10th, might be our ideal number, first number. And it goes all the way up to 122.
$49. 149 at the bottom.
149
right?
at the bottom. There you go. And the good thing about having a rough draft is we can take a moment and allow mistakes to happen. Not mistakes, but corrections. So I'm thinking, okay, I want to make a stem and leaf. I want to start with 16, so I'll start with 1. And I want to be able to include all the way up to 14 for 140. So we know that 1, it stands for 10, and I want to build up all the way to 14. That will stand for 140. And then we keep track of the ones place. So we'll have 2 for 20s, 3 for 30s, and so on. So if I want to write 16, I will write 1, 6 for 16. To write 19, I will write 1 and 9. I will just add it there.
So would you start at 16 to get to 40?
One more time.
So you started at 6. You would start at 6 because it's 16.
Mm-hmm. Yes.
And then what do you work up to again? I'm sorry, to 14.
Oh, we're just going to list all of our numbers. So if you want to, you can start with the very first one, 76. Okay, so 4, 5, 6, 7. Okay, I'll write a 6 for 76. That one's done. 49. I'll write a 9 for 49. That one's done. 102. I want to go all the way to 10 and build 2, right? So I'll save this one for later. 58. I do my 5 for the 8. 88, I'll save it for later since I don't have much space. 66, next to the 6, I write a 6. And we can just keep track of our numbers that way. Because I know if we try to clear our 1s in one shot, we might overlook them, or our 2s in one shot for our 20s. It's a lot of numbers, right? Our eyes kind of tend to overlook some numbers as we're searching. So that's why I say you can make a rough draft. Just start working with it and see what you have. Next slide. The data entries go from low of 16 to a high of 149. Yeah, we talked about that. Use the rightmost digit as a leaf. So it gives an example. 76 means 7 and a 6. 149 means 14 and 9. List the stems 7 to 14 to the left of the vertical line, and for each data entry, list the leaf to the right of its stem. So here it shows our answer. And what I don't like about this, the reason why it's nice to have a rough draft or a first draft is because look at these numbers. Aren't they all in order? And I don't know about you, but it would be really hard to keep track of those numbers in order. So I would maybe do a first draft where I can allow these numbers to be mixed up, right? All the way to 14. Do a rough draft. And for your ones, I would say that for those, don't worry about the order. Don't worry about the order. Make it a rough draft. So you can just plot them. You can just go through your chart and just kind of just go through each one, right? And make sure you have every number accounted for. And then once you have them all listed, and they're going to be in scattered order, they're not going to be, your ones are not going to be in order from lowest to highest, right? But you can go ahead and then create your final draft and make sure that they're all in order from lowest to highest. Now, what's cool about a stem and leaf plot is if you turn it to the side, so let me try turning it to the side for you. Wait, I don't think it'll show. If you turn your graph to the side, or maybe tilt your head, you can kind of think of this as a bar chart. I mean, a histogram, right? You can see which ones there's more of. And that's something that's really cool because it tells you so much. It tells you how many data entries you have and exactly what data entry it is, so you don't have any lost information. And then if you look at it, you also see what there's more of, like a histogram or a bar graph. So even though these might seem quite silly, they provide a nice list of information. However, stem and leaf plot might not be ideal if we have like 1,000 entries, right? Say you're doing some research for a company, you're dealing with, I don't know, types of soil or types of rock, and you're going through all these different regions, all these different cities, all this research, right? There's so many cities to consider. So you would have maybe hundreds and thousands. A stem and leaf plot wouldn't be a good representation because there's too many numbers. For that, you want a histogram. All right, next slide. Organize the data set in previous examples using a stem and leaf plot that has 2 rows for each stem. Describe any patterns. So what we're doing here is just making 2 rows for each stem, and it's another way to do it. Sometimes it's nice to break down your information. So what this means is if you look carefully, you see how we have 2 ones? You see how we have 2 twos, 3 threes? You can break it down so that you have 2 rows of each one. How do you keep track of it? There's no precise way. If you look closely, for example, at our 2s, it seems like they keep that rounding rule in effect. So in the first row, we want numbers between 0 and 4. And our second row, they want numbers between 5 and 9. So take a look at our stem of 3, our 30s. If we take a look at those only, we see that our first row has numbers that are less than 5. So 4, 3, 4, 3, 3, 3, 3, 3, 2, 0, 0. They're less than 5. And the next row has those numbers that are 5 and larger. So just another way to keep track of your work, to split your stem and leaf.
When it's repeated, like you see where it says 3 and 0, right?
Yeah.
That's 30, right?
Yes.
Okay, and then you know how it says 3, 3, 3, 3? What that mean? There's 4 33s.
Exactly. So if you
Okay,
want to,
that's what I was confused on. That's what I didn't know if they're repeating numbers or.
yeah, we can have repeating numbers. It's okay. So it just means we're keeping track of them. So if you want to actually write them out as a number, you know that means 30, 30, 32, 33, 33. How many do we have? 4?
Yeah.
33, 33, and 34. So all of this is summarized by that set of numbers. So it saves the trouble of writing those numbers down. But again, graphs are just a tool to keep track of your data.
Yeah.
All right. So let's go ahead and read our slide. It says list each stem twice. use leaves 0, 1, 2, 3, and 4 in the first stem and row, and the leaves of 7, 6, 5, 5, 6, 7, 8, and 9 in the second row. And instead by using 2 rows per stem, you obtain more detailed picture of the data. So it allows you to create more spread. So be careful in case if it tells you a specific instruction asking you to have 2 stems. So it's saying to list each stem twice. That was that rule that let you know to graph it that way. Next slide. So here it just shows your answer. Now something it didn't emphasize is you can always graph a key so that your reader knows what you're talking about. So sometimes a key is helpful so you can see, okay, they're going by tens. So if I have 1002, I know it's 102. If I have 1 and 6, that's 16, so forth. So a key could be nice to have for your readers so they know how you're splitting your stem and leaf, but it's not necessary. Now, another way of graphing, so we saw how stem and leaf was helpful because we can see exactly what our number is, and it also gives us an image, right? We can think of each one of those numbers, list of numbers as a row, as a chart, and we're building some type of like histogram or bar graph, right? So let's know what there's more of. Another way we can have that similar representation is with our next slide, a dot plot. A dot plot, each data entry is plotted using a point above horizontal axis. So think of this as your stem and leaf on its side. But instead of plotting a number, we're just keeping track of how many we have for this number. So here we have this data of 21, 25, 25, 26, 27, 28, 30, 36, 36, and 45. Now look at your row on the bottom. We have numbers that contain all of the range within our data. It includes our slowest to our highest, right? They're starting with 20 and they're ending with 45. And that works perfectly because all of our numbers are found within 20 and 45. Now all we're going to do is keep track of each number. So we have 21. I'm going to write 1 dot under 21. Cool. I have 25. I'm going to write a dot under 25. Another dot for another 25. I have a 26. I draw a dot over 26. And that's another way you can keep track of your data. Again, what's nice about this is that it tells you exactly what number it is in this case. And it also gives you an idea of which one there's more of. So we can see that we have 2 25s, there's 2 of them. And we can also see there's 2 36s. And you can see each data. So if you wanted to, if you didn't have that data, you can still take a look at your chart and see what you're working with. Okay, now let's take that same data from example 1, the number of text messages sent. So we established with the help of one another, we saw that our highest number was 149. And working together, we found our smallest number was, wasn't there a 16?
16, yes.
Yeah,
Fourth row, second one. Bottom.
First row, second one. Thank you.
Bottom.
You see?
Yeah.
That's what I mean, where you have to take a moment to look at your data. Right, we have our high and our low. So if we wanted to make a horizontal type of dot graph, we would say, okay, what numbers do we want to include such that we can include our highest and our lowest, right? So maybe we can start with 50 and work our way all the way up to 150. Well, that's a lot of numbers. We can also go ahead and skip some numbers. So we have an idea of where they may fall, kind of like a number line. Actually, this is exactly like a number line, but if it repeats, I just write another dot over it. I'm sure when you were sitting in class, you're like, why are we going over number lines? What's the point of this? Well, it's funny how statistics has a lot of little things that we learned in elementary math, and it kind of makes you think about them differently. So here we have a number line, right? And we have a number line, and every number we see, we take account for. So we have 76. I want to find my 70s, and 6, a bit more than 75. I have it right here. So you plot your number for 76. 49, you find your 40s, closer to 50, and you plot your point. Now, because this is such a large range, right? We were trying to set it up in that previous slide. We were like, well, 15 to 150, that's going to be a lot of tick marks. So maybe when you find yourself in a situation where there might be too many tick marks, consider going by 5s or by 10s so that you're not stuck drawing little tick marks all day long, right? So that's why we would take our eraser and be like, let's go by 5s. 20, 25, 30, 35, until you reach your highest needed number. Just like we have here. From your slide, it reads, from the dot plot, you can see the most entries occur between 20 and 80, and only 4 people sent more than 100 text messages. You can also see that 149 is an unusual data entry. So the whole point of this whole chapter is being able to have data and try to come up with some conclusion, some type of summary, right? So just like our conclusion says, that most entries occur between 20 and 80, right? So this means most people send about 20 to 80 text messages. That's what most of our data is. And our last number that we had, or 149, that was weird, right? There must be something funny with our data entry. Or maybe they just asked a bunch of adults and one teenager, right? Okay, you can also do this with technology, but we're going to skip that for now. The next graph that we have is a pie graph, a pie chart. Pie charts provide a convenient way to present qualitative data graphically as percents of a whole. A circle is divided into sectors that represent categories. Sectors is a fancy word for pie slices. It's a pie slice, right? Each area of each sector is proportional to the frequency of each category. Frequency referring to your percent. So the chunk of your slice is going to represent the percent of your whole pie. So let's do an example. The number of earned degrees conferred in thousands in 2014 are shown in the label. Use a pie chart to organize this data. So let's take a look at our chart. So we see it's talking about degrees earned in 2014, and it says that 1,003 were associates, 1,870 were bachelors, 754 were masters, and 174 were doctoral PhDs. Okay, so we want to make a pie chart. Now, if I want a pie chart, I know the whole pie is 100%, right? And I want to make slices according to the percent. So we have to take a moment and find the frequency of each one, find the percent, right? And that's our next step. Construct the pie chart using a central angle that corresponds to the category. Find the central angle, multiply by 360 degrees by the category's relative frequency. For example, the central angle of an associate's degree is 360 times 120.264. You might be asking, hey, where did this number come from? So we're going to take each relative frequency and we're going to multiply it by 360. And that's going to give you your degree of each pi. So here it tells us the relative frequency for each. Remember, to find your relative frequency, how about we do associates? You have to find the sum of all your numbers. So let's go ahead and do that. I'll take out my calculator. 1003 plus 1870 plus 754 plus 178. That's 3,805. Now to find this number, this relative frequency, I'm going to take my sum of 3,805 and take my number that I have for a bachelor's, which is 1,003, and divide. Punch that into your calculator, find your percent in decimal form. 1,003 divided by 3,805, we get 0.2636, and it continues on. So that's where they get this number. They rounded, right? So instead of a 3, they look at the next number. It's bigger than 5. So we have 264. And you did that for, they went ahead and did that for each category, for bachelor's, master's, and doctoral. Now we have our degrees. Now you might be thinking, well, what do I do with those degrees? Well, the idea is you can start making fractions with these. If you know a whole circle is 360 degrees, then if we want half of it, well, what's 360 divided by 2 for the half? It's 180. So I know half is 180. What if I just want a fourth? A fourth would be 360 divided by 4 would be 90. You can kind of use that to guide you, that sense of what each one is. And lastly, if you want an eighth, half of 90, that would give you 45. So you can kind of start making guesses, right, as to what it is. Now let's take a look at our numbers. We have 95 for an associate's. So you see how this kind of looks like a fourth? Because that is 95 degrees. And we said that's a fourth of 360. And start working with your smaller ones, with your larger ones, and you can start including your smaller ones. All right, so we did associates. Let's do bachelor's. Bachelor's is 177, and we said that one half of it is about 180, right? So 177 should be about half of it, which is what we have here for our bachelor's. And that's 177 degrees. And then you can kind of start filling things in. Our master's is 70 degrees. We know that 1/4 of it is 90 degrees. So let's do something that's a bit less than a fourth for our master's to match that 71. And then we can leave a small little chunk of 17 degrees for our doctoral. And for these, you can kind of take really rough estimates as to what you should let that be. Take ideas from like halves, fourths, eighths of a circle and start cutting it up that way. It doesn't have to be exact. We can, if we were in class together, we would go ahead and use Excel to graph a prettier chart, but rough drafts are okay for now. Okay, let's move forward. A Pareto chart. A prior chart looks very familiar for something we've done in the past. It looks a lot like a histogram. The big difference is these, we don't have our bars touching, so that makes it different. It's a different type of bar graph. A Pareto chart, a vertical graph in which the height of each bar represents the frequency or relative frequency. The bars are positioned in order from decreasing height position with the tallest bar positioned at the left. So two things are important for a Pareto graph. It gives us a frequency or relative frequency, and the bars are positioned in decreasing height. So those are two special qualities about this special type of graph, a Pareto chart. Now remember, a frequency is how many there are total for each category. Total for category. Relative frequency, it's your percent in decimal form. All right, let's go ahead and take a look at our previous information and apply it to a Pareto chart. In 2014, these were the leading, different information. These were the leading causes of death in the United States. There's accidents, cancer, chronic respiratory disease, heart disease, and a stroke. And we see the value for each one. Use a Pareto chart to organize the data. What is the leading cause of death in 2014? All right, so let's think about what we're going to graph without looking at our answer, which is the next slide. So if we're making a chart, this is when you want to start thinking about, where do I want to start our numbers? So I know I'm going to list accidents. I want to list cancer and chronic liver. Maybe make a list of each one. Maybe create a rough draft. And for accidents, for each number, do I want to start with 1? And then 2, and then 3? All right. We will be doing this all for a couple of weeks because we're in the 100,000s for each one, right? So maybe we might want to do a little break, show a little break, and then start with maybe 130,000 or 100,000 and go by 50,000. Also, a good thing about a rough draft is you have to make sure that it's in decreasing height. So I have to make a list of which one's larger and smaller. And in case it's not obvious, you can do a little rough draft and see what order you want to go in, how you want to rearrange it. So these charts, even though they're relatively simple to read, they do require some thought. They require a lot of thought as to what kind of graph do you want and what are your classifications for that one. And it's okay to do a dummy rough draft chart just so you can take a moment to see, okay, what do I need to change? Let's go ahead and take a look at our solution. All right, so they wrote their numbers in thousands, right? So we have 70,000, 140,000, and so on. And we see that each one's listed in order, with heart disease being the first one because it's the largest quantity and goes to each smaller quantity. Cancer, chronic or respiratory disease, accidents, and stroke. From the prior chart, you can see that the leading cause of death in the United States in 2014 was from heart disease. Also, heart disease and cancer caused more deaths than the other 3 causes combined. So this is what's useful about charts. We can take some information and kind of give a visual accompaniment to it. And sometimes that makes things a bit more real, a bit easier to understand. Another type of graph is paired data sets. Each entry in one data set corresponds to one entry in the second data set. A graph using a scatter plot on a scatter plot, the order pairs are graphed as points in the coordinate plane, and they're used to show the relationship between two quantitative variables. So let's go ahead and take a look at a scatter plot. The British statistician Ronald Fisher introduced a famous dataset called Fisher's iris dataset. The dataset describes various physical characteristics such as petal length and petal width in millimeters for three species of iris. The petal lengths from the first dataset and the petal widths from the second dataset. So we see how both of them are graphed. You can graph the width of petals in one and the length of a petal with another. So you can go ahead and compare two sets of graphs at the same time. As the petal length increases, what tends to happen with the petal width? Each point on the scatter plot represents a petal length and a petal width for one flower. So we see all of these numbers here, and we see all of these numbers here. Now, what this tells us is that there's a big difference between them, right? They're not relatively close. They have this big gap between them. So from the scatter plot, you can see the petal length increases, the petal width tends to increase. Another type of graph is a time series graph. So the data set is composed of quantitative entries taken at regular intervals over a period of time. The amount of precipitation measured at each day for a month, for example, you can use a time series chart. So what this allows is kind of like, honestly, this is the closest thing to your algebra experience of graphing a line, right? You have some sort of relationship between these values. So let's go ahead and read your slide. The table lists the numbers of motor vehicle thefts in the millions and burglaries in the millions in the United States for the years 2005 through 2015. Construct a time series chart of the number of motor vehicle thefts and describe any trends. Okay, so you kind of want to make one of them your x-axis and one of them your y-axis, as it goes on to explain. Let the horizontal axis represent the year and let the vertical axis represent the number of motors. Then plot the pair data to connect them with line segments. So you can go ahead and do what looks like a regular typical graph. So to help you out, it says let the horizontal axis be the year. So that's going to be our x. Right. Let the horizontal axis represent the year. And it says, and let the vertical axis represent the number of motor vehicle thefts in millions. So this is going to be our y. So each one of these is going to be a point. Remember we did this in class? So we can let this be a point. 2005 and 1.24. 2006 and 1.20. So each one of these will be a point in our graph. Since we're trying to make a summary for motor vehicle thefts. And that's what we have here. Each one was one of these points that we, each one of these was a point that we plotted from our previous chart. So I'll put here for 2005, for 2006. And as we see that as the years have continued, there have been less thefts. And then from there, you can make your own conclusion as to why that is, what happened. All right, so let's make a quick summary. We learned a bunch of graphs. I'm sorry, I heard someone's mic go off. Is there a question?
No. I thought you were gonna end. I was gonna ask something about slide 30, but go ahead and finish.
Oh, let's go ahead and ask about slide 30. What's your question?
It was so I understand the year and I understand the motor vehicle thefts in millions, so it's 1.24 million, right?
Uh-huh.
Okay, burglaries and well, I don't know, get where the 2.6 came from.
Okay, so sometimes they give you more information than what they ask. So you have to think, okay, if you ever like are thinking, why am I given so much information? What's going on? I'm kind of at a point where I don't know what direction I'm going. What's the point of this?
Oh, that's
Ask
my fault. I
yourself.
didn't read it. I
No,
didn't
no,
read
no,
it.
no, no, it's okay. I didn't emphasize it. It
Oh,
says,
okay.
what's your question? So we want to construct a time series chart for the number of motor vehicle thefts, right? Okay, so it gave me all this information, but the only one I care about is these right here, these motor vehicle thefts.
Okay.
Okay, so I want to make a time series one, so I have to worry about the year, and I have to worry about what topic it wants me to focus on. It wants me to focus on the motor vehicle
Okay.
thefts. Yeah,
Got you.
and it's something you'll see so much in your stats classes. They give you a lot of information that isn't always
Needed or relevant.
exactly, yeah, exactly. And if you're ever at that point, you have to think, okay, what am I doing? What am I being asked for? What's this telling me? Good question. All right, so a quick summary. We learned about a lot
Thank you.
about graphs. You're welcome. The ones that I want to emphasize are stem and leaf, dot plot. Pareto is when you'll see a lot. Not a lot, but it's good to know. Pareto and something like a series chart would be nice to just know. Now, if I'm being truly honest, none of the graphs that you saw here, you're not going to be seeing them every single day in your stats class. No, you'll see them kind of a lot in the beginning, and then maybe at the very end, you might start seeing a couple of series charts. But just to be able to know them and know how they work, I mean, it will save you trouble to when you see that type of chart to be like, okay, what is it telling me? But just the whole purpose of a chart is so that once you have some information, you can provide a summary and give your reader some type of visualization of what you found. That's the whole purpose of a chart. All right. So any last minute questions before we call it a day?
Sorry, I'm bugging. Number 2 is a dot, and number 3 was a what for the summary?
Oh, I don't know. But you
I'm
can
sorry.
always go. That's okay. You can always go ahead and look at the video. So in case something's bugging you, like, whoa, what happened? We have that. I said stem leaf plots, a dot plot, a Pareto, and a time series were the ones that you'll kind of see often.
Okay, thank you.
Yeah. Okay. So thank you so much for, oh, stop screen, stop share screen. Thank you so much for being here with me today. At any moment, if you have any questions, feel free to email me, or if you'd like to, you can always go ahead and watch this video again. The older videos, I did remove them from Zoom because I'm working on getting them onto YouTube because I ran out of Zoom data. I ran out of space there, but I'll post them on YouTube soon. I'll let you know once they're there. It takes a while to upload onto YouTube. All right, well, have a nice day. It's a nice gloomy day to be stuck in bed all day, so hopefully you're able to. All right, well, have a nice weekend.
Thank you. Enjoy the rest of your day. Bye. Good morning.
Thank you, you too, Ruben. Bye-bye.
Bye.
Bye, Abby. Bye, Sarah. Bye, Felicia. Bye, Cameron. Bye, Victoria.
Bye. Thank you.
You're welcome. Bye-bye.